All right, good morning, my grade 10 students. Mr. Mitchell here, broadcasting from my garage. I thought it was the only quiet place I could broadcast in the house, and I was halfway through my last lesson, and my wife came in through the garage door, opened it up, and ruined that video, so I'm starting from scratch again. The joys of trying to teach through COVID-19. So moving forward, you and I are going to experience distant learning together. How it's going to work, I don't know. I'm sure I'm going to make lots of tweaks as we go along. Right now, behind me, I have a whiteboard set up, and I'm going to try to teach these lessons kind of the same way that you would learn them in school. So I figure with math, trying to explain some things to you is better than just trying to send you some notes and have you figure it out. That being said, if you're unsure of a concept, please feel free to email me. I'll be monitoring my email all the time, or send me a message through EdSpeak, and I'll try to get back to you. The problem with that, though, is it's in written form. I think for this, one of your best things that you can do is, if you're really confused with the concept, Google it. Khan Math, Khan, has a lot of good videos that you can watch. There's other sites out there as well at different times. If you can use that math app on your phone, it might be able to help you out as well. And definitely turn to each other. I can't live broadcast to you, but that's something you can do with each other. So text each other, FaceTime, whatever it might be, and try to get the answers that way. But if not, definitely reach out to me and I will do the best that I can. I know you're going to have a video here, but what you don't necessarily want is a bunch of videos that you're going to try to go back to in June, come exam time, if there even is one. I don't know that at this point either. I strongly suggest pencil to paper as I'm going through this lesson. Take notes, figure it out. We talked about already at the beginning of the year how you have to practice math. So for what it's worth, I'm going to try doing this video again, and we'll see how it goes. All right, so we're going to be doing trigonometry instead of quadratics. I know I said I was going to start with quadratics first, but I think trigonometry is going to be a little bit easier to teach over this method. And hopefully we'll be back to school in May and June, and I can teach a good portion of the quadratics in person. If not, we'll figure that out as well. But we're going to start with trigonometry here. Before we get into the actual trig functions, we're going to do a day or two of lead-up work. So that's what we're going to start with today. As you can see here, we're going to start with similar triangles. So just a little bit of terminology. Congruent. Congruent means that an object is the same size and the same shape. So we have two triangles here, triangle ABC and triangle D, E, and F. Now these two triangles are the same shape, and I don't mean that they're triangles because there's lots of different shapes of triangles. These two are the same shape. The way I know that they're the same shape is corresponding angles are all the same. These are the same shape, because angle A is equal to angle D, angle B and angle E are equal to each other, and angle C and angle F are equal to each other. That's what makes it the same shape. As far as the same size, because the side lengths are the same in each triangle here. So we can see that side AB right here is the same as or equal to DE. And we can do the same for our other pairs. And AC and DF are the same. So these two triangles are congruent. Same size, same shape. And the way we write that down is we can say that triangle ABC and triangle DEF. Notice that I went A, B, C, D, E, F. I wrote them in the same way. And congruent. The symbol for congruent is this little squiggly line with an equal sign underneath. So that is the congruent indicator. All right, let's move on from congruent to Similar. So similar triangles. They have the same shape. Once again, the angles are going to be the same, but they are a different size. So two triangles again, A, B, and C. And we have here X, Y, and Z. Angles are the same. We can see that. We can see that angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z, or Z. These are similar triangles because the angles are the same. However, they are different sizes. So plugging in a few numbers here, 3, 4, 5, 6, 8, and 10, you can clearly see that triangle 2 is bigger. So let's look at that. We can see angle or side A here, side AB. And what I'm going to do is I'm going to set up some ratios. I can see here that AB, I'm going to do a ratio of AB to XY, sort of a left side of the triangle to a left side of the triangle. And I'm going to tell you right now that is equal or proportional to the bottoms of the triangle. So if we did BC and YZ, you would find that the ratio of left side to left side is the same as bottom to bottom. And it would also be the same as right side to right side, AC to XZ. And if we go back and we plug in the numbers, so 3 over 6, 4 over 8, 5 over 10, you can see that in lowest terms, all of these have a ratio of 1 to 2. That's telling us that this triangle is twice the size of this one. We call that a scale factor. And the scale factor here is indicated with the letter K. So the scale factor here is 1/2. This triangle here is 1/2 the size of this one. Now you may ask yourself, well, what if we did these ratios backwards? Perfectly acceptable. So instead of doing the first triangle on the top, I can do the second triangle on the top of these. So if I did XY right here to AB, I'm going to get 6 over 3. And if I do YZ on the bottom to BC, I'm going to get an 8 to 4. And likewise, for the third side, I would get a 10 to 5. And in this case, in lowest terms, we have 2. Our scale factor here is 2. This is twice the size as this. So both methods are perfectly acceptable. All right. So just doing a little bit more work with that scale factor before we move on. If I do triangle A, B, and C, and I can do another triangle here, R, P, and Q. These are similar triangles because the angles are all the same, so we know they're similar. And if I say 2, 4, and 5 here, and I'm going to say 15 and 6. Let's try to find out the scale factor here. How much bigger is this triangle than this triangle? And I know you can see, a lot of you can see right away that it's 3 times bigger, but let's actually go through that process. All right, so in this case, I'm going to do a left side to left side ratio here of 5 to 15. And I'm going to label that as left side and left side. You don't have to label it. This is just for my instruction here. And let's say that it is proportional to the bottom. So we have of each. So 2 to 6. So that is the bottom to the bottom. I'm doing this to point out the fact that we have to make sure that all these numbers are in the correct spot, that we don't want to accidentally flip these two. You can see along the top here, my 5 and 2 come from the first triangle, my 15 and 6 are from the second triangle. I don't want to mix that up and have first triangle, second triangle type of information. So everything has to be in the right spot. And in this case, we don't know the third side, but just using those two sides there, we can see that we have a scale factor of 1/3 in lowest terms. That tells us that this triangle is 1/3 the size of this triangle. And of course, if we did it the other way around, we would get a scale factor of 3, telling us that this one is 3 times the size as this triangle. Now, let's try to find out what our missing side is here. So I'm going to just take this first ratio. You could use any of the two. I'm going to take that one. And so that is a ratio side CA to RP. And plug in the numbers. We have, we have 5/15. And I want to say that that's proportional to CB and RQ. Now CB is 4 long, RQ, we don't know, it's X. So in order to solve these, lots of different ways to solve proportional statements. I'm just going to use a nice easy way of cross multiplication. So you're going to multiply across 5 times X is 5X's, and 15 times 4 is 60. And now we can solve algebraically, and we discover that X is equal to 12. In this case, we can say that triangle A, B, and C is similar. It's that little squiggly line. So congruent is a little squiggly line with an equal sign underneath. Similar is just the little squiggly line on its own. And that's similar to P, Q, and R. All right, moving on. All right, so let's find an unknown side length. Find unknown So, 2 triangles here. I'm going to make them similar triangles because the angles are going to be the same. Let's call this D, E, and F. R, P, and Q, I suppose. And I'm going to say that this is 8, this is 9, this is 10 long, and this is 6. And I don't know these side lengths. I want to find those out. All right, first of all, before we do that, I want to, 1, prove similarity. And we do that by looking at the angle. So angle D is equal to angle R, angle E is equal to angle P, angle F is equal to angle Q. All 3 sides are the same, or sorry, all 3 angles are the same. So we have similar triangles. Let's find the side lengths because we can clearly see that this and this are not the same size. So find the side lengths. All right, I only have one proportion at this point that I can do. We have DE, which is our left side, is proportional to our P. And we can see those numbers are 8 to 6. I'm going to set up a proportional statement, and I'm going to say that's proportional to the bottom. So we have EF of our first triangle and PQ of our second triangle. And plugging in numbers here, I have EF is 10 long, and PQ is, we don't know, it's B. So now what I want to do is solve for B. I'm going to put, 8/6 is 3/4. So I'm going to put that in the lowest terms. And I hope we can see down here. Cross multiplying, 4 times b is 4b's. 3 times 10 is 30. B is 30 over 4, divided by 4. B is 7.5. So I hope that's showing up on camera. We can see here that B is 7.5. We can do the same thing for the right side. So I'm just going to use the same ratio from the left side here. I'm going to say that the 8 to 6 left side is equal to 9 to A. So once again, we have a left side, right side, and along the top here is all triangle A, and along the bottom is our second triangle. So making sure everything is set up properly. Once again, I'm going to put 8 over 6 in the lowest terms. Probably should have just done that right off the bat. And cross multiply, 4 times A is 4A's, 3 times 9 is 27. A would be 27 divided by 4, and we get 6.8, I believe. So using our proportional statements, we can determine the side lengths of the missing sides. So that is that. All right, one more concept, then we'll do a practice question, and we are done. So let's look at the area of similar triangles. Or actually, I shouldn't say similar triangles. This is similar figures, but I am going to use the triangle since we're going to be going into trigonometry. So let's start with 2 right angle triangles. They are similar because the angles are the same. We have some side lengths here of 3, 4, and 5, and 6, 8, and 10. We can figure out our scale factor. So left side to left side, 4 to 8. Bottom to bottom, 3 to 6. Slant to slant, 5 to 10. We have a scale factor of 1/2. Or if you did do it in reverse, no biggie, we get a scale factor of 2. All right, let's use that scale factor of 2 here. Let's find the area of these. So this is our first triangle, this will be our second triangle. Let's find the area of each one. So the area of triangle 1 is base times height divided by 2. Remember, for a triangle, base and height are always at a right angle to each other. So our base here is either 3 or 4, and our height is the other one. So 3 times 4 divided by 2. 3 times 4 is 12, divided by 2 is 6. And for our second triangle, base times height divided by 2, we have 6 times 8 divided by 2. 6 eighths are 48, divided by 2 is 24. And we can see here that from an area perspective, that triangle 2 is 4 times the area of triangle 1. If we take triangle 1's area here and we multiply it by 4, we get 24. So this second triangle is 4 times bigger. And that leads us to an interesting little rule here, and that is, if I was to take this area of triangle 2 and the area divided by the area of triangle 1, that would equal the scale factor squared. So 24 over 6 is equal to k squared. And we know that 4 is equal to k squared. K is 2. Here's our K. So we can use that little rule there that in order to do some problem solving. So once again, I took the area of the second triangle divided by the area of the first triangle, and that gave me k squared. It would work if you did it in reverse, so it would work with the fraction of 1/2 as well. And I think maybe the practice question that we do here, we'll try to explore that. So one more question here, and I think we're done. Let's do a practice question to put this into use. And then I think we're going to be done here for the day. So, 2 triangles here. Let's do H, G, and I. And let's do, oops. K, L, and M. I'm indicating that they are similar triangles because the angles are all the same. I know this side length is 4 and this side length is 6. I also know that the area of this triangle is 12 square units. I don't know the area of this one. First of all, because the angles all match up, we can say that triangle GHI is similar to triangle KL and M. All right, let's figure out our scale factor here. So we have 4 to 6, which in lowest terms, our scale factor is 2/3. We don't have the other sides to work with. We can only work with the one side in this case. So let's plug this into our formula. In this case, because I put when we did the scale factor, in the last question we did, I did an A2 divided by A1 equals k squared. Because we had a scale factor of 2/1. The second triangle was twice the size of the first triangle. I'm going to switch this formula up here to A1 over A2 is equal to k squared. What am I doing? K squared. And the reason why I flipped this is because we have in our scale factor here, in the last question it was a scale factor of 2:1, where this was the second triangle and this was the first triangle. In this case, our scale factor is 2/3 because this is taken from our first triangle. The 2 is just the 4 lowest terms, which is from the first triangle. And this was taken, the 6 or the 3 was taken from the second triangle. So we can plug these numbers in here. The area of our first triangle is 12. We don't know what the second triangle is. And we do know our k, so we can sub that in. It's 2/3, and that is squared. So using our little formula, we can reverse engineer this. Starting to simplify here. On my left side, I can't do anything. On my right side, remember when we have a fraction inside a bracket, both the top and the bottom, the numerator and denominator are squared. So 2 squared is 4, and on the bottom, 3 squared, 3 times 3 is 9. All right, I'm running out a little bit of room here. At this point, we can cross multiply, and I'm going to bring this up here just for space's sake. 12 times 9 is 108, and a squared times 4 is 4 times, I guess, or sorry, not a squared, the second area. Algebraically, we can move that 4 to the other side. It becomes a divided by 4. A squared is 27. So I have just found the area of the second triangle here. And that is 27. And I realized I didn't write this down. I hope I said it. but our objective here was to find the area of this second triangle. All right, so that is that. I'm going to post this. I'm also going to post your homework. And I do luckily have a copy of a textbook here at home. So I will post pictures each day too of the homework questions and a picture of the answers. Once again, do your homework. Try to figure this stuff out. Rely on each other. Rely on me, and we're gonna work forward. We're gonna work through this getting forward. All right. Have a great day, everybody. We'll talk to you later.